All right, hey gang, glad you could join me again today. What we're going to get into today is solving equations involving absolute values. Okay, you can see it right there, what we're going to work through. Now, they've got a nice example over here. Here's what I want to do. I want to first of all talk about what an absolute value bracket is. Okay, so an absolute value bracket, I hope you guys recognize from years past, if you had an absolute value bracket of 3, you would say the answer would be what? It'd be 3, right? Okay. And if you had an absolute value of -3, you would say 3. Okay. A lot of times students have a definition for the absolute value brackets being whatever the value is, you just make it positive, which is true in some regard. However, I want to make sure that we understand the actual definition for absolute value. So again, maybe you want to make a little note to yourself. Don't forget that this means the absolute value. Okay. The definition of absolute value is this. It's the distance from 0. Okay, the distance from 0. So if you're thinking about this, if I go ahead and put 0 down here, and I were to say, how far is 3 from 0? And you would go ahead and say, hey, it's 3 units from 0. 1, 2, 3, right? And you can't even see that there because my big noggin in there is in the way. So if I was to ask you how far is -3 from 0, you would say, well, it's 3 units from 0, right? You cannot travel a negative distance. This is something we're going over in geometry right now, where I've got kids solving for x using what's called the segment addition postulate. And they're getting a negative value of x. They plug it back in. They have a negative length. I'm like, how can you travel a negative length? You can't travel a negative length. Okay. Well, the same thing is true here. Whenever you take the absolute value of anything, it becomes the positive. Why? Because you can only travel a positive distance, and it's the distance from 0. Okay. Now, as you look down here at exercises 1 through 9, okay, these are all pretty much the same type of problems. In fact, I'm going to go ahead and switch over here so you can see just that. Okay. We're substituting values in, and then we're evaluating what the expression is going to be after you substitute them in. So if I was to go ahead and take a look at number 3 here, we know that r is -2. So if I use my absolute value bracket, I have -2 for r, and you can put parentheses around it. I have n, which is -3, and t, which is 3. Okay. Now, if I simplify this, -2 plus -3, that's -5, plus 3 gives me -2. Okay. Now, working this out in parts, what's the absolute value of -2? Well, that's 2, but there's a negative out in front of it. So you can either put it, well, I'll just put it like that. The answer is going to be -2. Okay. The unfortunate part about this is that you cannot double check your answers really. Okay, you just have to go with it and trust your order of operations and so other things like that. So as I look down at number 9, this looks kind of daunting here. We got a big old expression that we have to simplify. So I'm going to do this. W, which is 4.5, minus n, which is 2, minus 5, absolute value. Then we have Q, which is -1.5, minus R, where's R at? R is -3. Now, I can tell you already, this is right where there's going to be a mistake that is made. Okay, so as I look over here, if there is another negative R, which there isn't, but we have a V. Is there a negative V? No. X is positive. Q, do we have a negative Q? Right there. Be careful of that. That's minus Q. Since Q is negative, it's going to be minus negative, whatever Q is, 1.5. Okay, so just be aware of that. So if I want to simplify this, we're going to treat these absolute value brackets just like parentheses. So if I do this, 4.5 minus 2 gives me 2.5. -1.5, a double negative makes plus. So -1.5 plus 3 gives me a positive 1.5. Now from there, we're going to do the absolute value. So we have 3 times 2.5. Obviously becomes positive. Both these will be positive. 1.5. Okay. And if we multiply these before we subtract, 3 times 2.5 is 7.5. 5 times 1.5, 5, 2, yeah, so 7.5. And we're going to subtract them. So our answer is 0 right there. Okay. Oop, sorry, that ran off there. Our answer is 0. Okay. So it's not very hard. Plug it in, simplify. I want to see all this work here, guys. As you work through these other problems, make sure you're showing me your work, because eventually, if you miss one, I want to be able to go back and figure out what you did wrong. Okay. All right. Moving to the back side now. Okay. So we've got some really good examples up here, and I can walk you through these 2 examples here real quick. In example number 1, it says solve for x, then graph the solution set. So what we have here is this. If we know that x plus 4, the absolute value of that is equal to 1, then our value of x plus 4 is either going to reside at 1 or -1, because that's the distance from 0. So that's why when we get rid of the absolute value brackets, we have a 1 and a -1, okay? Notice the left side of the equation did not change. It remained constant, the same, okay? From there, we go ahead and solve it, and if I plug in -3, so this is how you can check it. If I take the absolute value of -3 plus 4, if I simplify that, -3 plus 4 gives me 1, and the absolute value of 1 is just 1, which is what we had here, okay? And if I take this -5 plus 4, this gives me -1, which the absolute value is just 1. Okay. So how do we graph this? That's one way of checking it. How do we graph it? We're going to graph x equals -5, so there'll be a solid line or solid dot on -5, and x equals -3, so a solid dot on -3. Notice here the solution set has the brackets around it. Okay. So that's one way of also showing all the possible answers is in what we call the solution set. Okay, so the solution and the set of solutions, that's how many we have. So as I look down here, I'm going to pick out one of these to go ahead and do. I'll pick out number 6. Okay, so let's look at number 6 here real quick. Okay, number 6 says t plus 2, the absolute value of that is equal to 4. So what are we going to do? Well, we're going to do t plus 2 is equal to 4. Or, I didn't make a point of noting that before. As you look up here, we have the word or, meaning either possibility can take place, okay? So, or t plus 2 is equal to -4, okay? Now, what are we going to do in both situations? Well, in both situations, we're going to subtract 2. So we end up with t equaling 2 or t equals -6, okay? Now, the set of solutions, oftentimes we show it like this. Possibilities would be 2 and -6, okay? So I'm going to go to -6. I'm going to make a solid dot right there. I'm going to go to 2, make a solid dot right there, and I'm done, okay? The 2 possibilities there. Now, as we look at example number 2, if I go back here, okay, example number 2 says this: write an equation involving the absolute values for the graph. So now we're working backwards. We're starting with the graph here, and working our way back to the original equation up here, okay? So in this case, we are told that 4 and -2 is our x values. So the possible solutions right now will be 4 and -2. Okay? Now, what they're asking you to do, it says find the point that is the same distance from -2 as it is from 4. Well, we call that the midpoint, right? The middle point between these two. So if I count 1, 2, 3, 4, 5, 6, if I go halfway, that 3 right there is the middle value, okay? So that middle value we go ahead and put in right here. It says here, the distance from 1 to -2 is 3 units. The distance from 1 to 4 is 3 units, okay? Now, what's interesting about this is this. When I plug it in, that became a negative. It's the opposite value inside the brackets here. And let's see here. The distance right here, the distance is what we plug in here, okay? So keeping that in mind, let's take a look at number 15 here. So if I find the midpoint, I'm going from -7 to 1. Now the first thing that my mind thinks of is that this length right here is a total of 8 units, okay? So that means if I go 4 units, either way, I'm going to be at the midpoint. So if I go 1, 2, 3, 4, right there, or if I go 1, 2, 3, 4, we've got the same value, okay? So again, if I go back to my example, okay, making sure that this is right, I can go ahead and say that the middle value goes inside the brackets, okay? Now here's the deal. As I set this up, remember it was x minus 1 up there when it was positive. So I'm going to do x minus -3, okay? It's going to become the opposite of what we currently have. And what the difference is, this distance right here to each point is what we set it equal to. 4 units away here and 4 units away here. So this becomes a 4, okay? Now you might be thinking to yourself, is there a way to check this? I'm glad you asked. I can go ahead and solve this. We can go backwards just like we did in example 1 up above. So I can go ahead and do this. The absolute value of x plus 3 is equal to 4 is either going to be x plus 3 is equal to 4 or x plus 3 is equal to -4, okay? Now from there, if I subtract 3 from both sides, doing the same thing to both, I end up with x equaling 1 and x equaling -7. And voila, that is exactly what we needed, 1 and -7. So I hope that made sense to you. If not, you can come back and ask me questions. You can always go on YouTube, look up for your own videos. But that was short and sweet, and I look forward to seeing what you can do next time we talk. So anyways, have a great night, folks, and we will talk to you later.